Welcome to myprojectbazaar.com. Now we are going to discuss about the project lung cancer detection and classification from chest CT scans using machine learning. Now we are going to discuss about the abstract of the process. The classification of the medical image selections of the optimal features improves the performance of the classification process. The selection of the best feature reduces the time complexity as well as the algorithm complexity of the overall process. The CT images were used for the identification of the diseases in the lung images is most familiar in the medical field. Features were extracted from the images based on the wavelet features and then the LBP features, that is nothing but the local binary patterns. The extracted features were then classified using the 5 different type of classifiers. In this process we are using the 2 different type of classifiers named as the SVM and KNN. There are 2 type of the classifiers named as SVM and KNN used as a compound method to classify whether which kind of diseases is occurred in the image, whether the image having the normal as well as the diseased, whatever it is, it will be classified the types of the disease. The overall performance of the process were measured based on the performance metrics like accuracy, sensitivity and specificity. The accuracy, sensitivity and specificity of KNN as well as the SVM will be evaluated separately. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The project consists the modules such as input image, pre-process, feature extraction, classification, then finally disease classification. So first of all, the input image consists of the taken from data set. So the data set consists of both the normal image as well as the abnormal image. After taking any one image from the data set, we just move to the second stage of the project, that is the pre-processing. In this pre-processing we are going to do the image resize. The reason of the image resize is to maintain the size of the image into an aspect ratios. Maybe the image dimension is high or low, whatever it is, it will maintain the aspect ratios. That's why we done the image resize to avoid the unequal dimensions. After the image resize, we just move to the feature extraction. In this feature extraction we have 2 kinds of features in this process. One is wavelet based features, then the pattern based features. So the wavelet based feature is extracted, then continued with the local binary pattern which will be extracted from the pre-processed image. After getting these 2 features from the image, these 2 features are combined together to generate the test features. After generating the test features, we do the classification by using the 2 different type of classifiers named as SVM and KNN, support vector machine and K nearest neighbor. After applying this 2 classification method, we are getting the result as whether the input is normal or affected. If it is normal, it will remains the same, or else if it is affected means it will classify the which type of affected region is there in the input image. Now we are going to discuss about the initial running procedure of the process. At first, open the MATLAB 2015b and change the current directory. If you want to execute the process, just right click in the main file.em and select the option run. Once you selected the option run, the dataset folder will be open. In that dataset you can select any one image from the dataset. After the selection of the image from the dataset, the process will be undergone automatically. Once the everything was completed, we just move to the first stage. So the first stage of the project is the input image. We have already taken the input image from the dataset. So this is the input image. Figure 1 represents the input image. Then the figure 2 represents the resized image with the title of resized image, which having the resize of image 256 cross 256, which means the number of row will be the 256, number of column will be the 256. After done the image resize, we just move to the third stage of the project. In this pre-processing, this is another kind of pre-processing, that is the grayscale conversion. Even the image is looking like a grayscale image, maybe the image will be the RGB channels, so that's why we are sure we have converting the image into a grayscale image. After done the grayscale conversion, we are going to extract the feature from the image. This is the local binary pattern image form. So we are extracting the local binary pattern from this image. This is the image which represents the LBP. After that, we have to extract the features from that LBP. This is the values we have represented the local binary pattern. So overall the image size is the 256. Totally 256 values will be extracted from the image. After the extraction of the LBP, the test feature will be generated. So in this test features, the values of LBP as well as the values of wavelets will be combined together to generate the test features. After generating this test features, we do the classification by using the k nearest neighbor classifiers. So the k nearest neighbor identifies the type diseases like this, then the SVM is identified the disease type like this. After applying these two classification, we have to estimate the performance of these two classifiers. So the first value represents the accuracy, this represents the sensitivity, and this represents the specificity. So the performance of SVM, so here this is the accuracy, this is sensitivity and specificity. So the performance of SVM and KNN will be looking like this.